Thank you for joining us today. We're going to be talking about some common questions that we hear from customers when they try to deploy applications in their multi-cloud environments. My name is Ravi Soundararajan. I've been in VMware for a little under 18 years, and I have focused primarily on vCenter and vSphere performance. And I will let Vishnu Priya, my co-speaker, introduce herself.
Hi, everyone. I'm Vishnu Priya Muthukrishnan, and I'm a staff engineer at VMware. I've been at VMware for over 7.5 years now, and I primarily work on application performance.
Thanks, Vishnu. So like I said, we're going to be talking about the common questions that we get from our customers. It's going to be organized into two parts. I will first speak about vSphere concurrency. How many operations can I do at once? And I'll also discuss what you can do to find out if you're bumping up against those limits. After that, I'll hand it over to Vishnu to talk a bit more about UI and UI performance troubleshooting. So without further ado, let's talk about by far the most common question I get from customers. How many operations can I do at once? And to understand that, let's first take a quick look at a very, very simplified view of what vCenter looks like. You have your clients. This can be UI clients, they can be API clients, etc. They talk to vCenter, and of course, vCenter is in some sense the front end to the vSphere or ESX hosts that you're talking to, each of which is connected to a number of data stores and a number of networks. And of course, vCenter manages some aspect of those data stores and networks as well. So this is the mental model you should have as you consider the rest of this talk. So now let's dive right in. How many operations can I do in vCenter at once? Well, there's two hard limits to keep in mind. Whether you're doing this through the UI or through APIs, etc., you can issue up around 640 concurrent operations to vCenter before vCenter will start queuing those requests. Another hard limit is vCenter can support up to 2,000 concurrent sessions. So that's 2,000 logins, whether it be by a UI or an API. It also includes remote console sessions, so remote consoles to VMs. vCenter can accommodate up to 2,000. After that, it will start rejecting requests. So if you bump up near that limit, you're going to start seeing your logins fail. So those are some hard limits. But those are vCenter global limits. So if you sent them to vCenter and everything else was perfectly concurrent, that's what you would get. But there are also some per host limits that I'd like to talk about. Think of a host when trying to do operations as having a finite capacity. That host has capacity 16 slots. So if you do a clone, a relocate, or a vMotion to a given host, it costs that host 2 of those slots. And I'm going to have a diagram to show this next. If you do a storage vMotion, in other words, and I should phrase this differently, if you're changing both the host and the data store, it will cost you 8 slots. So it's more expensive than just doing a compute vMotion. If you are doing a linked clone, it costs 1 out of those 16 slots, but it does require you to have a pre-existing snapshot. If you're using the API, you have to do the snapshot first. And then finally, if you're cloning a VM that's already powered on, it still takes 2 slots, but vCenter has to take a snapshot first. So you might see an initial delay while it takes that snapshot before it starts issuing those clone operations. So like I said, there's a vCenter-wide limit, and then there are per host limits. So let's illustrate those per host limits with a picture. Imagine I'm cloning a virtual machine from host A to host B. So I got this VM on host A, I'm going to clone it to host B. As I said, a clone costs a host 2 units, and it actually incurs a cost both on the source and on the destination. That's a bit different for vMotion. We can get into that in the Q&A if you're curious, but for a clone, it's a cost on both the source and the destination. So it costs the first host 2 units and the second host 2 units. In this diagram, I depict the slots. Unfortunately, it's red and green. I try to fix that in later versions of these slides, but the point is you can see that now each host has 14 free slots. Each of them is involved in this clone. Those clones take 2 slots. The total capacity is 16. So they each have 14 slots left. Now compare that to a case in which you are doing a clone of a VM from a host to itself. In this situation, the host is both the source and the destination. So the host is charged twice. It costs 4 units. And so in this case, if you had 2 hosts in your system, one of your hosts would have about 12 free slots because it's being charged as both the source and the destination. while the other host, host B, has all of its slots available. So you can now see why it's important for you to spread clones across your infrastructure, not do them all to a single host. I point out this example because I very commonly see customers will have maybe one golden template that they use to deploy across all of their hosts. And unfortunately, if you have a single golden template, it by nature resides on a single host. And so if you do all of your clones from that host, after 8 clones, you will no longer be doing, you will not be able to do any more. You'll have to wait until one of those 8 completes. And so you're artificially limiting your concurrency. Instead, if you spread out your templates across multiple hosts, you can get much better concurrency, and you'll get much closer to the vCenter wide limits as opposed to being limited by the single per host limit. Now that's the per host limit, but there are other limits that we must consider. There are per data store limits. So think of a data store like you think of a host, in that it has a finite capacity. It's got, in our case, 128 slots available. So if you do a vMotion on that and that data store is involved, it costs that data store 1 slot. vMotion isn't really that intensive on the data store because, of course, it's mostly moving things across. It's mostly moving memory, not moving disk. A storage vMotion, or rather a vMotion that changes both host and data store, does involve the data store a bit more, and so its cost is more. So you can see by looking at these pictures that on a single data store, you can do up to 128 vMotions that can be in flight at once. And if you're doing storage vMotion, or if you're changing both the host and the data store, you can do up to 8 at once. That's 128 divided by 16. Those are per data store limits. There's also per network interface limits. If you have a 1 gig NIC, I know those are less and less common nowadays, but if you have a 1 gig NIC, you can do up to 4 operations on that NIC. If you have a 10 gig NIC, you can do more. You can do up to 8. I'm going to show a picture of this on the next slide. And if you do a vMotion, so that's capacity. A 1 gig NIC has 4 slots. A 10 gig NIC has 8 slots, and a vMotion costs you one of those slots. So that tells you can do up to 4 or 8 vMotions at a time on that NIC, depending on its speed. We do recommend, when you're setting up vSphere, to have a vMotion NIC or vMotion port group, and also to set up a provisioning NIC or a provisioning port group. That lets your vMotion traffic go over one NIC or port group, and it lets your clone traffic go over another, so that they're not going over the management network. Now, a question I often get is, can we change these limits? We have a pretty fast SAN, or we have a pretty fast network. Can we change these limits? We tried to tune, so the answer is, it's not really. You can change them. You can change them to config options, but it's not officially supported. And the reason we do that is we want you to have the best end-to-end experience. So we try to tune so that an individual clone or vMotion or relocate is very, very fast. And if the individual ones are very fast, that means if you issue a bunch of them at once, each of them completes more quickly, and the end-to-end time to complete all of them is much shorter. If instead we allowed you to issue as many as you wanted, the problem there is that then you end up having to fight for network traffic, you end up causing contention on the disk, et cetera, and you end up actually taking longer to perform the same operations. So we try to keep this at this number because it hits a sweet spot in terms of the speed of an individual transfer or clone and the parallelism that we get in our system. So let's go over the per NIC limits one more time. So if I want a vMotion a VM from host A to host B, there is a NIC cost, as I show you here. There's also a host cost. So as we said before, a vMotion costs 2 units. So each host is charged 2 units. The NICs themselves, that vMotion is 1 unit. So you can see here that the NIC is charged 1. And so in theory, each NIC can be, this is a 10 gig NIC. The limits don't change whether it's a 10 gig NIC or a 25 gig NIC. So you have up to 8 slots available. So you can see that these host and NIC slots sort of work together to help throttle operations. Now, that was a simple case where you just have one pair of vMotions, one vMotion at a time. But let's talk about a slightly more complicated case. Imagine I'm vMotioning a VM from host A to host B. And at the same time, I'm vMotioning a VM from host C to host B. In this case, you'll see that host A is involved in a vMotion, so it's cost 2. Host B is involved in 2 vMotions, so it's costing it 4. And host C is involved in a single vMotion, so it costs 2 slots. You can see that the NIC cost is 1 for host A because it's only involved in 1 vMotion. You can see that in host B, that cost is 2 because it's involved in 2 vMotions. And you can see that for host C, it's involved in only 1 vMotion, so its NIC cost is 1. And I depict that here. So as I said, vCenter has to compare all of these different limits before it issues an operation. Now, if you're using content library, the content library process resides in vCenter. It allows you to deploy across clusters. If you have a content library on a single data store, and if you clone within that if you have a content library attached to a cluster and you do a clone within that cluster, that's typically a local copy. But if you clone it across to a different cluster that does not have a copy of that content library item, that's actually a network copy. So you would expect that to be slower. So one way to get around that is to put a local content library in each cluster. And that way, all of your deployments will be local deployments. The content library itself can perform up to 20 concurrent transfers, and each individual host can be involved in up to 8 transfers. So you can see that the limits are fairly similar to what we showed on the previous slide. And as I said earlier, it is best, if you can, to have a content library repository per cluster, as opposed to having a single cluster and then deploying across clusters. And if you have the option, please use a provisioning NIC in your vCenter so that all of this deployment traffic goes over that provisioning NIC and is not shared with the management traffic. How do I know if I'm reaching these limits? Well, you can use the UI as I show you here. If you see in your UI resource reservation as the details, then that means that you're coming across the limits that I've been talking about in the previous slides. If, however, you're seeing something that's in a state of copying files, that means if there's any limitation, it's because it's limited by either disk or network bandwidth. It's not limited by the resource reservations I've been talking about. Now, that's a simple UI way to know if you're hitting against these limits. Let's talk a little bit about how you might do this by looking at our log files. We have a log called the profiler log. It's in the same location as your vCenter VPXD logs, as I show you here. The name is VPXD profiler with a number after it. And the format is basically a timestamp, some additional metadata, and then a bunch of key value pairs, as I show you here. I should point out, by the way, that much of what I'm talking about in this talk has been talked about in a blog that I co-wrote. And we also have another blog that talks about vMotion concurrency. And those links will be posted in the chat for you to peruse afterward. Okay, back to the talk. So as I said, we have a profile that's a bunch of key value pairs. And here's a couple of the ones that I tend to look at when I'm interested in knowing how concurrency is doing. We have information about the sessions that are connected to a vCenter, whether it be a UI or an API. We also have information about what method calls are being made to that vCenter and whether certain things are being queued within vCenter, as I show you here. So let's talk about those. I said earlier that if you try to exceed 2,000 sessions, your logins will be blocked. How would I know that? Well, we do list a counter called num sessions. And if that num sessions counter hits 2,000, then you may be in trouble. Now, there's a little subtle nuance that I'm going to describe. The limit is actually 2,000 authenticated sessions. Whenever a typical interaction with vCenter involves getting some information using an unauthenticated call and then creating a session from that. Those authenticated calls just to sort of get information about the vCenter, those don't cost you. Those are not limiting you. It's only when you actually use a login of some sort. So if you're hitting 2,000 sessions, and if you see a message out of HTTP sessions in your vCenter logs, your VPXD log, then you know you're in trouble. So the way I typically use this is I look in my profiler log to see if that number of sessions is creeping up. And if at some point it gets close to 2,000, I then look for this session limit message to see if I'm bumping up against that limit of authenticated sessions. Now, there is another limit. We have various proxies within our vCenter server. And if you see a message like num handlers, if you see a message like what I'm showing you on the screen, basically, you may have less than 2,000 sessions, but you may be making too many calls across those sessions. We have a limit of up to 2,000, about 2,048 calls overall to vCenter. So even if you're under the session limit, if you're making more than that 2,048 calls, you may see a log message like this, and that means that your API calls are going to be throttled. So there's a couple of limits to keep in mind here. That's not available in the profiler log. That's only available in this HTTP proxy log. So there I've talked about hitting session limits and how to debug that. Now let's talk about thread queuing. As I said, there are a number of queues within vCenter, and we log some information about them in this profiler log. We divide operations. The distinction isn't really important for this talk, but just for the benefit, there are certain operations that are considered long running because they could take a long time, like vMotion. There are others that are considered short running, like power on. And so we have different queues for each of those within vCenter. Ideally, what happens is a request comes into vCenter and is essentially automatically transferred to the host that's going to host or hosts that are going to perform those operations. And so you shouldn't see these queuing numbers really go over 0 very often, unless you get a huge burst at once. So in the profiler log prints out information every 5 minutes, as you can see on my screen. And as you can see, your long running is at 0. This is considered a healthy system. If it's in the small single digits, or if it's above single digits, but maybe for a time step or two, that's okay. Where it becomes problematic is, as you can see on my screen, if the numbers are consistently increasing, and if they're in the 10 to 20, 30, 40, 50 range or more, then it might mean you've got some concurrency bottleneck within your system, and you may want to explore that more. And maybe something is actually not working properly and causing requests not to be completed, which then takes up queue space. So this is a good way to kind of proactively see if something might be going on. Next, I'll just briefly talk about the fact that we've introduced a number of new APIs. We now have we have our traditional vModel 1, or sort of more SOAP-based APIs, and now we have more RESTful APIs. And as an example, many of you are probably used to using our SOAP APIs, which go through a proxy within vCenter and then talk directly to the VPXD process. You usually use this for cloning or vMotion or relocate or power on. But now we have additional APIs, more RESTful APIs. So with those, you go through this proxy, which reads the address to figure out where the request should go. And then we have an endpoint process, which reads the header to figure out more precisely which subsystem should handle that request. Your request, if it's, say, a clone or a power on using one of our newer APIs, will then get sent over to the VPXD process. But if you're using, for example, tagging or content library requests, then those will be shunted to the appropriate backend subsystem. So there's multiple ways to make requests to vCenter, and they have their own concurrency limits. When you're using these APIs, there are a number of gotchas that I will briefly discuss here. Please feel free to ask questions either during this talk or afterward. Vishnu will give you a link on that. But basically, when you're doing a client, it is preferable to use connection pooling so that you don't have to do as many handshakes to vCenter when you send requests. If you're using clients, if you're using automation clients, try to limit the number of group memberships, because each of those SAML tokens it can be quite large, and that can actually slow down performance. If you're starting to see 429 or 503 errors, you might have to back off, because we have some internal throttles within our endpoint processes to avoid vCenter getting overwhelmed. If you have the choice between logging in and logging out frequently or trying to create a persistent session, I would recommend using a persistent session, because logging in and logging out incurs a lot of those handshake overheads, and is also, you're creating and destroying objects kind of frequently. So it has implications on memory usage and CPU usage of vCenter. If you're using our wait for updates EX API, so in other words, if you're waiting for updates from vCenter, when you're done consuming an update, please call cancel wait for updates. If you don't do that, you run the risk of accumulating memory on vCenter, and these bugs can be difficult to debug, to find. If you're using our property collector interface to get information, please be very precise about which information you want to collect. It's best if you want a specific attribute, for example, of the config object, get just that attribute. Don't get the entire config object. It's quite large. It costs memory on vCenter. It costs CPU to serialize that request and send it back to your client. It's a lot of overhead. So be careful when you're using property collector filters. If you're using our event APIs to query events, please specify a time range. Don't try to ask, if you have the option, please don't ask for every event from the beginning of time. Please specify from this time to this time. And we have the similar recommendation when you're querying statistics. Please specify a time range, whether if it's past a day, maybe the last 2 hours or something, or if it's a past hour stat, then maybe you just want the last 15 minutes. But in any event, please specify a time range. So to conclude the first portion of the talk, and then I'll pass it over to Vishnu. There are vCenter related limits in terms of the number of concurrent operations, and then there are host, NIC, and data store limits. And vCenter will throttle based on many of those limits. If you know about these limits, and hopefully this talk has taught you a little bit about that, it may help you in how you code your applications to take better advantage of them, not be throttled, not be slowed down by them. And if you have questions about whether you're hitting these limits, you can either use the UI for some simple debugging, or you may be able to use the profiler logs, as I've shown you here. With that, I'm happy to hand it over to my colleague, Vishnu. Vishnu?
Thanks, Ravi. Hi, everyone. In this part of the session, we'll be going over some of the tips and tricks that I would recommend for UI performance debugging. So often one of the most common questions that I get is, why is my UI slow? So UI could be slow due to various reasons, but I'd like to categorize it into two major parts. So if you see there is a specific operation or a page to be slow, then likely that could be a server issue. It could be coming from, say, there is a plugin that is blocking or slowing down your data retrieval, or they could be like, for instance, if you're clicking on a parent entity and if it has a lot of objects that it's trying to list, then those long list of items could make the data retrieval slow. And there could be some sort of compatibility checks that are happening under the hood across high number of objects, and so on and so forth. On the other hand, if you find that your overall user experience to be slow, then I would attribute it to something called as the infrastructure issue. By infrastructure, what I mean is it could be the network latency between the browser machine from where you're trying to access your vCenter, between the browser machine and the vCenter itself. And a few other reasons could be something like there are like too many users that are logged into the system, or like a lot of mutation operations like clone, migrate, and so on and so forth, operations that are happening in the background. And also the type of browser that you use and the resource usage on your client machine from where you're looking at could also have an impact. Just to drill deeper, we'll go into each of these sections in the remaining portion of the talk. So where do you start, right? If you find something to be slow, first thing that I would recommend you to use is the Chrome browser, because Chrome has one of the best JavaScript built-in engines. Built-in JavaScript engine. So that is what we recommend for the best user experience. And for the first case, right, if you find some page or a specific operation to be slow, what are some of the things that you can look at? Right. So you can look at the request and the response time of the various requests that happen in the background, and also logs become handy after that. To drill deeper, how do you get the request and the response times, right? So in Chrome, you can go on to the settings, the top three dots, and then clicking on the DevTools will open up something called as the DevTools panel inside on the right hand side or beneath or somewhere, right? And it has like a lot of tabs in it, and the most interesting one or the useful one for recording the request and the response time would be the network tab. And it has like a record option where you can capture the requests like that are happening in the background. In this video, I'll just demo, like I'm trying to click on a host. I'm going onto the VMs page, and that should list a bunch of VMs that are residing on this host. And for this, I'm trying to start recording, and there is some sort of background request. I'm trying to clear it. And clicking on VMs actually captures all the network requests that are happening beneath. And if you see the bars that are in there, the longer the bar, the higher the duration it's taking to complete or waiting for the data to come from the backend. So just to get an understanding of where the things are slowing down, just clicking on that request would give you a good overview of what is that request containing, right? In this case, if you see, there is like a total result count of 19, and there are like several different objects that it's fetching from the backend. And for that, if you notice closely, there are like about 19 requests here, and there are like 19 VMs that are listed here. So this exactly corresponds to the metadata that's coming from, the data that's coming from the backend. Why this is very handy is because there are certain cases where you have plugins, or there could be a bunch of tags that have been created, or so on and so forth. And before even going on to a shell access to look at the logs or anywhere, just looking at the network tab for the longest request would give you a good idea of where the slowness could be coming from very quickly. So this is one thing that I would highly recommend. On the other hand, if next one of our friends is the logs. So vSphere UI logs can has something called as data service, right? So what is data service? So think of data service as a data sourcer, because the UI service has to talk to a bunch of different services inside vCenter. So be it VPXT, content library, tagging service, and so on. So the data sourcer acts as a middleman, like fetches all the data that it needs from different services and gives it in a form that UI can understand and display to the user. That's the whole scenario. And in order to understand like where the slowness is, now you have once you look at the network tab and some request is slowing down. In order to dig deeper on what sort of information it's fetching, going on to the data service.log inside the above folder would give you a bunch of queries. And if you narrow it down to the time where the operation, whatever the operation that you're doing, it would give you a bunch of queries. And in order to parse these or understand these queries, the one thing that you might want to look for is the query batch execution took too long. So this query batch execution statement gets logged for any operation that takes more than 3 seconds. And below is just a sample of the data service log snippet that I've added here. And I think there are two important things that I would like to point out. So one is the request ID, and the other is the client ID. So what is request ID? So one parent HTTP request can have multiple subqueries that are generated, and these subqueries can be mapped, and it becomes like you can look at the parent query and see all the subqueries that are coming up in order to understand if a specific subquery is the cause or not. And often like there might be multiple users that are logged into the vCenter, right? Like, so each of those clients are distinguished by the client ID. So you can be specifically looking at a specific user slowness and so on. So having looked at these two things, this would give you an idea or for debugging when there is a specific operation slowness. But in case you're seeing an overall user experience slowness, right? Like one of the first things that I would recommend looking is your network latency between your browser machine and the vCenter itself. So the latency between this has a great impact. Just to give you a ballpark number, think of if you have like 20 to 40 milliseconds latency between these two, your experience would be much better compared to there are like hundreds of milliseconds or something like that. So imagine you have like a linked VC, right? I have like 4 linked VCs in this diagram. And if I want to look at, say, VC number 3 in a specific geolocation, then what I would recommend is having a jump box in the same geolocation as the VC in order to minimize the network latency between the two. Secondly, like say for instance, your experience is low and you've looked at the network latency and everything looks fine, right? Now, the other thing to look at is your client-side resource usage. So what I mean by client-side resource usage is the CPU and the memory usage on your browser that is consumed by the vSphere client tab. And this can be done by going into a similar way where we popped up the dev tools. There's going to be something called as the task manager. And the task manager has the memory footprint and the CPU percentage that is getting used. Just to give an idea, the vSphere client should have something less than 500 meg. You should see, unless and until you see like extremely large numbers, the client side looks fine. On the other hand, just to look at the resource usage on the server side, right? Like you might have to log in via the shell into the appliance and then look for, and you can type in the vimtop command, which becomes handy because it gives you the breakdown of the CPU and the memory for each of the services that are running inside vCenter. And if you're looking at specifically vSphere UI, which is the H5 web client service that is slowing you down, and if there are like, for instance, just for an example, if there are like multiple users that are logging in, right? If there are so many sessions that are getting created, and if you had deployed, say, a smaller sized appliance, then likely the vSphere UI heap size could be smaller and you might be hitting the limit. In that case, this would give you that breakdown. And in order to configure and to even like list what is the heap size configured in your appliance, you can give the Cloud VM ramp size -L. And in order to configure it, you can give -C and give the value for any service, and then restarting the service should pick up the new values. Great. So before we move on, I want to talk about one of the examples, like say, because this is something that I encountered, and walking you through this example of how I found where the slowness was would be an interesting part. So here I'm taking an example, which is the VM navigation tree. So here it is like I have a data center, I have a folder, and I have a bunch of VMs that are sitting inside the folder. So one thing that I noticed was whenever I was trying to expand this folder, my browser was freezing, meaning I was not able to click anything else until this operation completed, and it did not respond to going back or whatever. If this is the reason, then I try to look at the network calls, like the I showed previously, like capturing the network requests. And most of the requests, or like all of the requests, completed in few seconds. It did take time, but it just completed in few seconds. It didn't take minutes or something. But the freezing was there for quite a while. So then I was thinking, could browser resource be a bottleneck, right? In that case, looking at the Chrome Task Manager, I could clearly see that the CPU usage was spiking. And what could go wrong, right? At the end of the day, I'm just having a bunch of VMs and I'm getting all the data from the server, but somehow something is going wrong on my client side. That is when I discovered that I had the placement of like about 45,000 VMs that I had in my data center inside the same folder. This is so as a best practice in VMware, what we recommend is the max supported limit for a folder is about 4,000 VMs. And it's always a best practice to distribute your VMs across multiple folders. So some of the things that I would like you all to take away from this talk is please use Chrome browser and also do load certificates. By loading certificates, what we do is like we enable, we say to Chrome that please trust this website, right? Like whatever the website that we are using. So in this case, what happens is it allows caching of static content on the client side. So thereby you might have like much faster experience, meaning when you have cache content, the next time browsing would be much faster. And also make sure to have the low network latency between your vCenter and your browser machine, and use faster machines if possible. Before we move on, I want to point you all to some of the resources for VMware on VMware program. To know more, please visit our website and blogs, and also feel free to reach us out via email or tweet us at VMware on VMware. Thank you.